So 1.4 in the textbook covers more domain and range. And this is where you get to polish it up. And what I want to do is not really go over domain and range again per se, but to go over some of the homework questions in the textbook to give you a better understanding of the types of applications of domain and range that they're asking you to do. Now, for instance, the domain and range in a word problem may be constricted or restricted by the context of the question. If I tell you that I'm going to throw a ball in the air, and let's just make a quick little sketch here of something that's in the shape of a parabola. So let's say I throw a ball off the roof of a building and it's, I don't know, 10 meters high, and I throw it out, it goes up in the air and it comes down and it lands right here. And this is time, and this is h at t. Remember, we're using function notation now. So this is the height of the ball over a time t. Now, obviously, this isn't a parabola that continues this way or this way. It's restricted by time. So the height can't be, it can't have a time less than 0, and it can't have a time that's past where this lands. So let's say that was 3.5 seconds, so 3.5. So after 3.5 seconds, this ball is on the ground, period, end of story. So the domain can only be from here to here. The range can only be from 0. That's assuming the ball doesn't go through the ground and keep going, which would be kind of silly. But it shows the height is going to be from 0 up to this height here. So say that was 10 meters. This might be 12.5 meters. So again, the domain and range can be restricted by the context of the word problem. So let's do a couple of different problems from your textbook, because I know sometimes teachers don't take up all the homework for you. So let's focus on a few that I normally give to my class. It gives them a good idea of what they should be able to find the domain and range of. The first one is from question number 7, and it says x squared plus y squared equals 36. So the first thing you want to do is look at this equation and determine whether or not it is a function, and what type of relation, if it's not a function, what should it look like? So you need to remember, when you see two things that are squared, the x and the y equals something. This comes from, again, the lessons you did in grade 10 math. X squared plus y squared equals r squared, which is, of course, the equation of a circle. Now, we've already talked about circles, and that circles are not functions because they do not pass the vertical line test. So the question here, though, it says graph the relation. So they don't say it's a function. Graph the relation and state the domain and range. Is it a function? So if I were to graph this, I would make a nice little coordinate plane here. And I need to know what the radius is. So remember, 36 is the radius squared. So that means the radius itself has to be, well, r is equal to plus or minus 6, so it's 6 units. So let's say this is 6 here, and that's going to be 6 up here. It's going to be minus 6 and minus 6. So if I could draw a circle, it would go kind of like this, right? It's hard to draw circles freehand. Okay, so that's my graph of the relation. And now I need to know what the domain and range is. Well, let's say first, let's answer the last part of it. It says, is it a function? I use a vertical line test. Here's a vertical line. It crosses twice, so it's not a function. Not a function. And the domain and range. So what values for x do I have here? So I'm going to write domain. D equals, I do my curly bracket, and I'm using x values. So this is x and this is y. So what can my x values be? Well, there is a limit to my x here, right? It can only go out this far, and it can only go this far. So it's between minus 6 and 6. So the domain is a set of x's, and it goes between -6 to +6. So you just put your x in the middle and write your less than or equal to. So x has to be greater than or equal to -6, but less than or equal to 6. And I also say x is an element of real numbers, and that means that I can draw these lines to make the whole function go around. If it wasn't real numbers, I'd have a series of dots, right? That's integers. This is real numbers. So similarly, the range goes the same way, right? So it goes between -6 and 6, and it's also an element of real numbers. So that's your domain, that's your range. The domain, remember, is the distance on the x-axis that you can use the values for, and the range is how far does the function go up and down. So there's the limits of it. So that's number 6. Let's take a look at number 9 from the textbook. Determine the domain and range of each function. So I'm going to do A, and it says -3x plus 8, -3x plus 8. Domain and range. Now, if you paid attention in the last lesson, you know that linear functions have domain of real numbers, and so does a range, because remember, a line goes everywhere, right? They don't ask you to graph this one, but I will just, let's say that's 2, 4, 6, 8. Put 8 here. And the slope is equal to -3 over 1. Remember, you can always write it over 1. So it gives you your rise, your run. But the rise, we're going to use the negative here, which means I'm going to go down 3 first. So I went by 2. So 2, 1 is 3, and over 1. So there would be my line like this. Oops, didn't go through the dot. I'll just move it over. Okay. So that's my line. And what is the domain and range? Well, the domain is x is an element of real numbers. I have all values of x that I can put in this equation. Remember, it says, what can you put in for x here? I can put in any value and get an answer for f at x. So the range is going to be f at x. Oops, that's funny. F at x. And f at x is an element of real numbers as well, because it goes forever. Remember, these arrows say it's going in every direction forever and ever. I'm going to skip to number D. I'll do one quadratic and I'll do one radical. So D says P at x. See, I told you they can use anything. F at x, G at x, P at x. P at x is equal to 2/3. 2/3 x minus 2 squared minus 5. So if you want to know the domain and range of this, it's probably a good idea to just spend 2 seconds to sketch it. Now, it's not going to be a real accurate sketch, but I do know where the vertex is, and I do know whether it's concave up or down, whether it's stretched or compressed. We'll get a lot into that when we do transformations. So right now, I can tell you what the vertex is. Do you remember the vertex? Vertex here. X are weird, so it looks like -2, but it's going to be, the vertex is going to be 2 and -5. So I'm going to find that 1, 2, 1, 2, well, let's go by 2. 2, 4, so this will be 2, 4, 6, -2, -4, -6. So 2 and -5 would put it right here. 2/3, it's positive, so that means concave up, like this, past the cup, right? There you go, concave up, past the cup. So that's going to be, that's a good thing to remember, concave up, past the cup. So it's going to be concave up. I don't really care where it's going to cross the x-axis. That's not part of this question. So I know it's going to go something like this. That's all I need to know, because I know that the domain of a quadratic is real numbers. So domain equals x. X is an element of real numbers. all values of x. I can put in any value and get an answer for p at x. And the range is going to be p at x such that, okay, now I have to look over here and see, well, where does it start and where does it go? So the height starts here. So if you want to, remember I told you if you cover this up, there's no function under here. The function starts here and it goes up. So I need to know the coordinate, the y coordinate here, which denotes the range, right? The height of the function. And we said it was -5. So this was 2 minus 5 here. So the range starts where y is -5. So if I drew a line here, it would be y equals -5. So I want p at x is greater than or equal to -5. P at x is an element of real numbers. So that's 9D. Now let's do one of the radical ones. I'll just flip this over here. So let's go to one of the radical questions. Let's do F. F says, this again is still number 9, and this is on page 37. So if you don't have the Nelson textbook, you can access it from Carleton University site. They have Nelson 11. So if you don't have an Ontario textbook, or if you want to see what the textbook says, you can go to that website. I'll try to provide the link to it later. Okay, so 9F says r at x is equal to the square root of 5 minus x. Now remember again, when you're working with radical functions, I need to know what makes this equal to 0, because that's the smallest number I can take the square root of, is 0. No negative numbers. So I'm going to write 5 minus x is equal to 0, and I'm going to solve this equation. So the easiest way would be to move this to the other side. So I would get 5 is equal to x. Double check, 5 minus 5 equals 0? Yes. So this function starts the lowest number I can put in. And now just to make sure, this is sometimes or most often a good idea to do. So I know that 5 will make this equation equal to 0. Now the question is it the numbers bigger than 5 that I want, or do I want the numbers that are less than 5? So let's try putting in 6. So if I try 6 into this equation, 5 minus 6, whoa, that's a negative number. So I can't go this way. I want the numbers that are from here to the left. This is my domain that I want. Okay, so I want the numbers 5 and smaller. So let's try 0, for instance. 5 minus 0, that's 5. Yes, I can take the square root of that number. Or if I put in -10, 5 minus minus is a plus. So that would be the square root of 15. So all of these numbers are the numbers that I want. So I'm going to say the domain is going to be the set of x's such that x is less than or equal to 5, and x is an element of real numbers. Now the range, I want to know how high does this go? So what I do know is that as I put in numbers, if I put in 5, I would have 0. Let's just do a quick little table of values. But once you've done this a few times, you won't need to do the table of values. You'll just understand it, because all this is doing is shifting or reflecting the graph this way, right? So my function's going to go like that. I know that, maybe you don't. So let's try some values. So if I put in 5, that gave me 0, right? 5 square root of 5 minus 5. So 5 minus 5 was 0. Square root of 0 is equal to 0. If I put in 4, the square root of 1, so 5 minus 4 equals 1. The square root of 1 is equal to 1. So I get 4 and 1. And then you keep plugging in values, and you'll see that the function's going like this, right? It doesn't go down. So that means my range is going to be r at x such that r at x is greater than or equal to, it starts at 0. That's as far, all these numbers are going to be positive, greater than 0. R at x is an element of real numbers. Okay, so that's 3 little questions from number 9. I'm going to do number 10, which is a word problem. It says a ball is thrown up from the roof of a 25-meter building. The ball reaches a height of 45 meters above the ground after 2 seconds. Okay, let's draw a picture because this is going to be, unless you have the textbook, you won't know what I'm saying. Okay, so here's a building. Here's a building, put some windows in it. A very fancy drawing. Okay, and here's the ground. So the ball is thrown upward from the roof of a 25-meter building. So this is 25 meters. This is the height at some time t, 25 meters. And it says the ball reaches a height of 45 meters above the ground. Ooh, I'm not going to have room to draw it, but let's say that's 45 meters here. After 2 seconds, it reaches a height of 45 meters and hits the ground 5 seconds after being thrown. So it comes down 3, 4, 5. That's where it hits the ground. 5. This is time, and it's in seconds. This is the height, and it's in meters. Okay, so sketch a graph that shows the height of the ball as a function of time. There we go. There's our ball. State the domain and range of the function. So this is part B, the domain. Domain. Okay, so we had time. So we're going to use, it's the set of time such that time goes from, now here's a restriction, right, on my domain. It starts at time 0, but the story ends after 5 seconds. So 0 and 5. Time is an element of real numbers again. So here we go. The ball went up in the air, came down, and hit the ground after 5 seconds. The range, well, that's how high does the ball go in this word problem? How high does it go? So the lowest is 0, and the highest was 45 meters. So at 2 seconds, it was at 45 meters. So that means that the range, h of t, is going to go from 0, that's the lowest. I always start with the lowest one. And it goes to a height of 45 meters. And h of t is an element of real numbers. Done. Now part C is the tricky part. It says determine an equation for the function. An equation for a parabola. So you have a couple of ways to do this. One way would be using the vertex form. Do you remember the vertex form? Vertex form of a quadratic is y equals ax minus h squared plus k. Now you might have to go back in your grade 10 notes to do that one. The other option would be to use the zeros, the zero function, or the roots, you might have called them. So here's my equation, and I have to, you're always trying to solve for a. Find this value. So I know a point on the graph, 2 and 45. I also know another point here, 5 and 0. Right, this is 5, 0. I also know another point, 0 and 25. So I have 3 points, and I only need 1 point, an x and a y, and I need an h and a k. Now remember that h and k is the vertex. Remember that from grade 10, h and k. So the vertex is 2 and 45. And a point is, let's use 5, 0. So x, y will be 5, 0. So I'm going to use all those little pieces of information. X equals 5, y equals 0, h equals 2, k equals 45. And I'm going to substitute these values into this equation to solve for a. Okay, because this tells you how stretched this is. Remember doing that? Is it stretched? Is it compressed? So I plug in all these values. So y is 0. I'm solving for a. That's good. I don't know that one. X is 5. Minus h is minus 2. And k is 45. So with all this information now, I can solve for a. So I'm going to bring the 45 over here, cross an equal sign, change the sign, becomes negative. 5 minus 2 is 3. Then I square it. 3 squared is 9. And 9 times a is 9a. To solve for a by itself, that's all I want, just the a. I'm going to divide by 9. And I get a is equal to minus 5. So now that I have the a, I plug the information back into the general equation for my parabola. So therefore, y equals minus 5. You always keep your x's and y's. So I have x minus 2 squared plus 45. So that would be the vertex form of this quadratic. So that's number 10. And the last one, number 11, we'll just do a couple of those. I think we've covered enough of the domain and range that you should be getting pretty good at this by now. So number 11, write the domain and range of each function in set notation. So let's do another quadratic one. F at x equals 3 times x plus 1 squared minus 4. Again, this is a parabola. It's been vertically stretched by a factor of 3. The vertex is important, and the concavity. Concave up, past the cup, right? So the vertex, I'm going to state what the vertex is here first. So it's minus 1 and minus 4. And it's concave up. Remember concave up? Like this. You can make a cup out of it. That's why it concave up past the cup. So I'm going to put my vertex on. Minus 1 and 4. Let's go by 2's. So let's say this is 4. This is minus 1. Minus 1 and, minus 1 and minus 4. I'm going to go this way. Minus 2, minus 4. Minus 1, minus 4. And it's concave up. All I want to know is the domain and range. I'm not concerned about what the x-intercepts are or where it's going to cross this x-axis. Not important. I want the domain and range. I know that the domain of any quadratic, don't even have to think about it, is real numbers. So that's the first thing I'm going to say. The range is dictated by the height of the function. So where does it start? It starts right here. Now we should have done a concave down one because then you'd look the other way, right? It's got to be, well, maybe we should do one of those right after. So minus 4 and up. That's the range, right? This is the range here. Minus 4 and up. So I'm going to say f at x. So f at x has to be greater than or equal to minus 4. And f at x is an element of real numbers. Okay, so here let's do one more, a negative quadratic. So one that's concave down. So 11D, this was 11C, and this still is on page 37. 11D says f at x equals minus 2x squared minus 5. So can you tell me the vertex from this? Remember that this is like this, right? So the vertex is 0 and minus 5. Zero and minus 5. So this is just a quadratic that's been shifted down 5, We're going to get into a lot of these transformations very shortly. And it's concave down because this is negative. That's a reflection. Oops, I forgot the negative in this line. Minus 2, x minus 0. So 0 and minus 5 for the vertex. And I'm going to start it up here. This can be my x. 1. Let's go by 2. 2, 4, minus 5. And minus 2, so it's concave down, and it's vertically stretched. Stretch means thinner. So again, the domain, you should all be yelling this out to me. I wish I could hear you. X is an element of real numbers. It's a parabola, always the same. The range, though, it starts here this time, right? And it goes down. So the highest point is minus 5. So range is f at x such that f at x is less than or equal to minus 5. F at x is an element of real numbers. Okay, so the range is going down, so that means we have a concave down parabola, and the range goes from here downwards. So that pretty much explains everything in 1.4. This is just more explanation of domain and range, more practice. And I think if you go over these questions, you should try them again on your own. Or maybe you've already tried them and you're just coming here to check what we've done. And that should keep you good. So hopefully this is helping you along. And please leave any comments below so I know that I'm reaching you and that you're understanding perhaps a little better than you did in class. Bye for now.